need a teacher.
Alright, so have you ever learned trigonometry?
I learned more from
Which is fairly complex, but it's also fairly algorithmic. Do you know what the word algorithmic means? Which means what?
That like you plug in you there's like a set thing and then you plug numbers into it.
Beautiful. Step-by-step process. Okay, so before we start that though, I have a simple question which you can discuss with your group, and that is, how would you find the height of the flagpoles out in front of the school? And notice it says accurately. So what I'd like, as it says, is for you and your group to come up with two strategies. Two methods for finding the flagpoles as accurately as possible. Discuss.
I guess you can take the height of the flag and then measure how many flag things it's tall. Yeah.
See how many
Because it's one of those real life problems that needs to know like glue a bunch of yardsticks together.
Yeah, I agree with that one.
We need to get like high up with flex glue. Is that thing you get high up? Flex glue. It's like
Flex tape.
yeah, it's like
Flex
they have so many other products.
Flex tape, flex seal.
Did you know that 999,999 rolls of flex tape cost $530 million?
What?
I don't know why.
Anyways, flagpole is pretty big.
999,999 rolls of flex tape is $530 million.
So it's good tape. And that's the problem.
And when you try to order that much flex tape, there's no shipping method available.
You tried?
Yes.
So wait, how many methods did we come up with? Rulers work good.
Ruler before.
I guess you can like Google
how
the average size of a flagpole is.
ask the person who made the flag.
Why do you know this?
Call the company that made the flagpole.
It seems like a lot of work.
Alright, Kara, what do you got? Give me one strategy. Shh. Go.
You could take yardsticks to the pole and play at the very top.
How would you tape yardsticks?
I don't know.
A ladder.
You cut the pole
Flex
and
tape.
then lay it down.
We believe we can do it.
Yes, if you believe in this,
We can accomplish anything if we put our minds to it.
Uh-huh. Now, eat that table.
I mean, not right now.
Oh, okay.
Oh, not really.
So you don't put your mind to that yet.
Not yet. I'm not there yet.
Is that a practical method? No. Is it a solid strategy?
Yes.
Yes. Taping meter sticks to a flagpole is a solid strategy. All right. Patrick, what do you got?
Oh, you said you could tape measure.
How?
Oh, with a ladder, and you just like.
So in order to measure the height of that flagpole, I have to get a ladder as tall as the flagpole.
Yeah.
But then if I have a ladder as tall as the flagpole, couldn't I just measure the ladder?
Oh, yeah.
Okay. And then what? So just get in a cherry picker, go up to the top, and then do what?
You like hold the top of measuring tape and then you drop it.
Drop the tape measure from the top. All right. What do you guys have?
Measure like the height of the flag. You like measure the height of the flag and then like you pull it and then as many times as it goes up you count that and then multiply times the height of it and then that's how tall it is.
That's good. So you would calculate how many flags tall the flagpole is and multiply that by the height of one flag. Good. Dave, what does your group have?
we had to tape the meter sticks
Uh-huh.
and just pull like So like put them all flat on the ground and tape them. Like even if we go over, just like stand them up.
Okay, just take a bunch of sticks, whether they're meter sticks or yard sticks or whatever, tape them all together,
Yeah.
and then
And you just stand them up.
just whip them right up there.
Yeah.
Yeah, so you've got this giant stick, and how is that gonna measure the height of the flagpole?
You see where it stops at the top, and then you bring it back down. Just count it. Foolproof.
Yeah, how are you gonna see where it hits where the flagpole hits?
You use
not that
binoculars.
You use
not like-
binoculars. Okay. All right. Andy, we haven't heard from you guys.
We did like the
Tape measure with a cherry picker. All right. Oh, hold on. You could use the measure app on your iPad.
Oh yeah.
I just said
How does that work?
You like put a point and then you like bring your iPad down and it draws a line and then you put the other point at the bottom.
And it will automatically tell you the height of something.
Yeah.
Do you have it on your iPad right now?
Yeah.
Patrick, stand up. Tell me how tall Patrick is. Let's see how accurate this bad boy. Pat, do you know how tall you are?
I'm like 5'6", 5'5".
Okay.
Oh my gosh, it says move iPad to start.
I think she's just taking pictures of me.
He's gonna be all over social media by second hour.
It's better on the iPhone. I'll get mine.
All right, go get your phone. I don't know how tall Patrick is.
Let's all just take pictures of Patrick.
Jack just wants
I don't
to
think one
flex his
person's
everything.
supposed to. Stand still.
You qualify.
I think you just have to.
Every time you.
I have to eat the ground too.
There you go. Tapping it harder will help. All right, that didn't work so well. Does it require dancing before you work?
Oh wait, it's working if it's like really close. Like
Jack,
if it's close.
You gotta put it up in his face. Yeah, I think you gotta go closer. I think it's too tall.
Wait, hang on.
You think he's too tall, but it'd work on the flagpole.
Measure his face.
Get that
Here we go.
detail.
Yeah, but
How would you measure his face to get really close?
That's a great question. That's why I'm trying to see if the app would work.
It just closed on me!
Oh boy, you broke it. You just broke all of Apple.
Face gets stretch Armstrong and then use this app.
What are you supposed to do in this situation?
Your face is 9.5 inches.
How tall is he?
9 inches.
9.5 inches. Awesome. All right, so that might not work so well.
No, his face is 9.5.
And then just measure.
Using what we have already learned,
Solid.
how could you find the height of that flagpole?
You find this.
Make a
You're not
triangle.
Sean, you're Augie.
Yeah. You make an equal out triangle with like the highest part, or whatever it's called, being the top of the flagpole, and then you can find the two of the
How would you make an equilateral triangle?
you eye it really well.
Well, where would you stand in order to make an equilateral triangle?
That is good. Like the picture. You stand back.
How do you see the length of it?
To make an equilateral triangle?
Or just the right triangle.
Well, which one? There's a big difference.
Well, like the equilateral, you have to cut off half of it, but the right triangle, you can just not have to cut off half.
How do you know it is?
Okay, so let's suppose you made it, the equilateral triangle's not gonna work, because we don't have 60 degrees and we already have a 90. So let's suppose you made a right triangle. How would that help you calculate the height of the flagpole?
You do like the, yeah.
Explain.
Oh. Well, if the pole is perpendicular.
We can assume that, yeah.
So, all you have to find is the hypotenuse.
No, you just measure out.
Yeah, because, yeah, but then you need to know how
Okay, so if we assume that we can accurately measure distance on the ground without putting Everybody, it's Mr. Will.
Wow, pretty fancy here.
You know, we're Prospect High School.
Oh yeah, yeah.
Take care. If we assume that we can accurately measure on the ground, and maybe the sticks taped together method isn't so good, how can we use that to set up, let's say, a 30, 60, 90 triangle?
Well, you measure out the bottom, and then
Okay.
we have an equation where it's like A is 2, and another A, and then you just use that.
Good, now there's one small problem there.
I said it wrong.
Where do you need to stand in order to get that 30-degree angle? How do we find a spot? How do we find that spot on the ground that we know it's 30 degrees? Use a protractor.
How do you
Okay.
use a protractor?
That works. I mean,
Just get like a.
Go ahead. But how would you know
Oh.
this? Go ahead.
if you use a protractor and then you like. I haven't seen that. Okay, so if you like tape string to the top.
Top of what?
The top of the flagpole. And then
Wait, hold on. So let's suppose we get a nice day this week and we go outside to measure the flagpole. Do you think anybody at Prospect is going to allow you to shimmy up the flagpole?
No, I just like
Look away, everybody.
I see a little.
So we can ignore like cherry pickers and climbing to the top, taping a bunch of sticks together.
Okay.
We want a practical method that we can go out tomorrow morning and say, that flagpole is exactly blah, blah, blah height. Okay, go ahead.
You walk far enough away and you just have the protractor. You just walk far enough away and then you find like where it makes the 60-degree angle, because that would be the 60.
I agree wholeheartedly. Now, what does that really look like tomorrow when we go outside?
Looks like us being stupid.
You could like look at what companies produce them and like look at the heights of their flagpoles.
Oh, cheat.
I mean,
It's using your resources.
So that's
What do you got?
it's like called the
find the
Really advertise
the
on flagpole.
shadow, the time of the flagpole, and then use the point of the shadow and like measure the. Wait, couldn't you do? The shadow, like, no, that's not right. Yeah.
So we got a couple options, yes? We'll approach this problem later, and we're actually eventually going to go outside and measure the flagpoles. If we can come up with a strategy that's going to work. In other words, I want this strategy to be accurate enough that we can get the height of the flagpole within an inch or two. Okay, within 5 or 6 centimeters, because we'll probably do it in centimeters. And we'll talk a little bit about that. It's not a difficult process, but it will require a little bit of work on our part. And the issue would be, how would you, I like your idea of the 30, 60, 90 triangle. We could also do a 45, 45, 90 triangle. If we could figure out an accurate way to get that angle set. Okay, where do I stand to exactly get that 30-degree angle? We'll talk about, go ahead.
Shadow.
We also have a shadow technique that we can use too, and there's also something called a mirror technique. So we'll explore all different techniques, and then the challenge will be who can find the most accurate height of the flagpole. Okay. But what we're going to do is talk about trig, and this is one of the options that will allow you to find the height of the flagpole. So this is just some general triangle that I happen to call ABC. Not every triangle is going to be labeled ABC, XYZ, PDQ, DOG, whatever. However the triangle is labeled, what we're going to start implementing is this naming technique. And the way the naming technique works is capital letters for the angles, like they've always been. And then now we're introducing lowercase letters, which are the side links. So if I label the triangle ABC, then the side B is opposite angle B. The side A is opposite angle A, and the side C is opposite angle C. In this case, C happens to be the right angle. That won't always be the case. And you'll know it's the right angle because it'll have a little box in the corner, or it will tell you that it is a 90-degree angle. So if I change the angle measures, or the angle names to X, Y, Z, you should be able to properly label the triangle. So what we did originally is we started with Pythagorean theorem, where we had two sides of the triangle. We knew it's a right triangle. We did a squared plus b squared equals c squared. Then we said, okay, what if we have these two special right triangles? A 30, 60, 90, or 45, 45, 90 triangle. What trig is going to allow us to do is look at all possible triangles. It doesn't matter how big the angles are, assuming that at least one of them is 90 degrees. Okay, so does the labeling make sense? You're not going to get a picture with every problem. A lot of times I'm just going to tell you you've got a triangle PQR with R being the right angle, and you'll have to draw the triangle and label all the sides accordingly. So in order to do trig is, actually there are 6 functions. We're only going to look at 3. And they are functions, meaning they do things mathematically. Like addition is a function. It takes 2 numbers, adds them together, gives you another number. Square root is a function. It takes a number, it figures out what number times itself will give you that number. The trig values are, or the trig functions are, again, functions. I'm going to take some number, I'm going to apply what's called the sine function to it, and it's going to spit out another number. That's pronounced sine, cosine, and tangent, but we abbreviate them sin, cos, and tan. Please don't call them sin, cos, and tan. Sine, cosine, tangent. And as I said, there's 3 others which we're not going to really concern ourselves with. That's for probably next year for many of you. So now the question is, we just need to figure out, well, what do they do? Okay, we know what the squared function is. It's a function that you take a number and then multiply by itself. So 4 squared, the squared function would be 16. Now we need to know what the sine function, the cosine, and the tangent function do. Okay, so there's our generic triangle again. Don't make this more difficult than it has to be. It's really simple. The sine, the cosine, and the tangent are simply ratios. That's it. That's all they are. So for instance, the sine of the angle A. Now why angle A? Because I just used that as an example. We could do the sine of B, we could do the sine of C. But the sine of angle A is determined by the length of the opposite side over the length of the hypotenuse. Okay, so notice, at angle A, there are 3 sides in relationship to angle A. There's the adjacent side. What does adjacent mean? Next to. There's the opposite side, and there's the hypotenuse. So for angle A, which side is the hypotenuse? C. Which side is opposite?
C.
No.
Side A.
A. What side is adjacent? B. Does everybody see that? Because if you don't, you're going to have a lot of trouble. If you see it, then this is easy. All right, let's go to angle B. Which side is the hypotenuse? C. Which side is opposite from angle B? Little b. Which side is adjacent? A. Okay. Now you see the naming pattern here. What side is opposite angle B? B. What side is opposite angle P? P. What side is opposite? Okay, so that's why we labeled the triangle that way. All right, so sine is opposite over hypotenuse. Cosine. Adjacent over hypotenuse. And lastly, tangent is opposite over adjacent. Even though I included them in this example, the A over C, the B over C, and the A over B are not going to help you at all because the triangles will always be changing. What you want to know is that the sine is opposite over hypotenuse. The cosine is adjacent over hypotenuse. The tangent is opposite over adjacent. If you've got those 3 things under control, then trig is pretty straightforward. The most important word on that slide is ratio. remembering that these are functions that generate ratios, also known as fractions. Okay, we good? Everybody caught up? All right, how do we use this? All right, here's a triangle. How long is side A? 4. How long is side P? 3. And how long is side E? 5. Okay, good. Now, how big is sine of A? Okay, so the question you want to ask yourself is, what's the sine? Well, the sine is opposite side over hypotenuse. What side is opposite from angle A? 4. Which one's the hypotenuse? Therefore, the sine of A is simply 4/5. Done. Cosine. Adjacent over hypotenuse. Which side is adjacent to angle A? 3. Which side's the hypotenuse? 5. Okay, so let's go here. We knew that, what did we say this was? Sine of A was 4/5. Cosine of A 3/5. Tangent of A. Tangent is opposite over adjacent. Which side's opposite from angle A? 4. The adjacent side is 3. Done. Okay, is that tricky? No. Now, it's tricky now because you don't know the functions very well. You'll learn them through practice. We good so far? Beautiful. What's the sine of P? Not 3. 3 over 5. Why? Joseph, why? The side opposite P.
Then you find the hypotenuse. Hypotenuse is 5.
Good. Then tell me what the cosine of P is. Good. And then finish this. What's the tangent of P? Three over 4? Yeah. Just a bunch of fractions. That's all. Nadine, what's next?
I'm confused with how you figure out like which one is the adjacent.
Okay, so let's take angle P. The first thing I do is always find the hypotenuse. That's the easiest. This is the hypotenuse. It doesn't matter what else happens in the problem. That's got to be the hypotenuse. Okay. Which side is opposite angle P? Go across the triangle. There's my opposite side right there. By process of elimination, then, this must be the adjacent side. Okay? Head.
For E, what, like, because 5 would be the, like, opposite side, then what would be the hypotenuse?
Excellent. That's why I included this question. Okay, we'll see it.
Okay.
So what happens if I try to take the tangent of angle E? So what's your question?
Like, what would be the hypotenuse?
Good. If we look at angle E, which one's the hypotenuse? 5. It's always 5. It doesn't matter what angle we're talking about. Which side is opposite angle E? 5. Beautiful. Which side's adjacent?
3 and 4.
3 and 4? So there's 2 answers? How's that possible?
3/5 or 4/5.
3/5. Okay. Do you really think we'd have 2 answers like that?
No.
No. So there's a problem there, right?
Yeah.
Yeah. The way we handle that is we stay away from the right angle.
Okay.
We're going to try not to use calculations involving the right angle. And we'll talk a little bit more about what happens when you take the tangent of a 90-degree angle, the cosine of a 90-degree angle, and the sine of a 90-degree angle. Okay. We're good so far? Question?
So what happens when you put numbers in E, A, and B?
Oh, we haven't done that yet. You want to know the angle measures?
I'm just saying, like, how would you solve that?
That's tomorrow. Okay. All right, so bust out your calculators. You'll see there's 3 buttons on your calculator that you probably never used before. Cosine, sine, and tangent. Find them? Got them? Okay, good. So take the cosine of 41. Hit the cosine button, type in 41, hit enter.
Give me an error.
Error?
So the correct
873.
You should get 0.7547. Who got 0.7547?
Definitely.
Who didn't? Uh-oh.
I
All
got
right.
-1.1.
So there's a possible fix for that. Up in the top row, you'll see the mode button. Hit the mode button. And in the, for some of you, it'll be the 3rd row or the 2nd row, you'll see radians versus degrees, or some of you, it'll say rad versus deg. You want degrees highlighted, and then hit enter. Yeah, we're not ready for radians yet. You want degrees.
Wait, Mr. Z,
Second quick.
Cos of 41.
I think you should, just like,
Probably not do that.
There you go, you're good to go.
Same as 2.
Okay, do it again, and make sure you get 0.7547. Okay, now, this is important, listen carefully. If your calculator is in the wrong mode, it will continue to generate answers. Those answers, however, will be incorrect. Many of you, when you took the cosine of 41, you got a value, it just wasn't the right value. So, you want to be sure you're in the correct mode. However, right before the next quiz, this is always a fun trick to play on your friends. Just reach over and put their calculator in radians mode. That's a laugh riot, I'll tell you. Fail the quiz, it's great, it's hysterical. If you really want to help your friend out, not only should you put it in radians, but change the language on the calculator. You can also do that. You can put it in a variety of different languages. Okay, so let's check to make sure we're all on the same page. Take the tangent of 74. Did you get 3.4874? And then last but not least, take the sine of 2 and make sure you get 0.0349. Okay.
Wait, so
Yeah, but you
always, do you want us to always go like
For tangent values, for trig values, yes. Okay, so let's go back to the previous discussion. Manny asked about taking the tangent of angle E. Okay. Well, you got a calculator sitting in front of you. Take the tangent of 90 degrees. What do you get for an answer? Error. It will not allow you to do it. Why won't it allow you to do it? Because we don't know, is 3 the adjacent side or is 4 the adjacent side? Let's try the other ones. Take the cosine of 90.
0.
Cosine of 90. 0. Why?
Because
the sine of 90 is 1.
And you can't do
We're getting there.
Can't do
What's that? Why is cosine 0? Any idea?
since you don't have adjacent.
oh, it's not over 5.
Well, what is cosine? Adjacent over hypotenuse. Which side's adjacent? We don't know. So why is the cosine giving us 0, but the tangent is giving us undefined? 0 over anything is 0. What about the tangent?
Over any number is 0.
But something over 0.
There's a something over here.
Interesting.
And then, as Ethan already said, what's the sine of 90? 1. Why is the sine of 91?
It's the hypotenuse over the hypotenuse.
Yeah. And again, the best way to deal with the 90-degree angle is just avoid it. That'll make your life a lot easier. So you don't want to be taking the cosine or sine or tangent of the 90-degree angle. We can figure out other ways to work that. Okay, so we got calculators working correctly. Now, this doesn't do us any good to finding the height of the flagpole. So big deal, I've got a triangle, I can set up some ratios. How's that going to help? Well, what it will do is allow us to solve a triangle like this. Now notice, that's not a 30, 60, 90 triangle. That's not a 45, 45, 90 triangle. That's just some yellow triangle with a 40-degree angle and a 90-degree angle. That's important to notice. It's got to be a 90-degree angle. If you understand the ratios, then these problems are just a matter of setting up an equation and solving the equation. Okay, so let's start with x. I'm going to use this angle. By the way, how big is that angle? 50, but we're going to stay away from that now. We're just going to work with given information. I'm looking for x. I know the hypotenuse is equal to 3, and so I'm going to set up an equation. What function of, back up, we know this is the hypotenuse. Is this x the opposite side or the adjacent side?
It's the opposite side.
Opposite or adjacent from the 40-degree angle?
Opposite.
Opposite. What function uses opposite and hypotenuse?
And.
Which one?
Sin.
The
Sine.
sine.
Not sin.
Okay. What you just did is the hard part. You identified the function, you identified the sides, the rest is easy. Sine of 40 degrees is equal to x over 3. Anybody not see where that came from? Opposite side over hypotenuse equals the sine of the angle. We know how big the angle is. We're good to go. How do I solve for x?
Couldn't you just put it into your calculator?
We're going to, but we're going to solve for x first. That's going to be the last step we do. How do I get x by itself here?
Multiply by 3.
Multiply both sides by 3. There's a reason why I put the 3 out in front. And some of you may have already run into this, is that it could be a parentheses issue. If I write the sine of 40 times 3, that can be misinterpreted as the sine of 120, and we don't want to do that. So I put it out in front. That does me no good, because you're not going to go to the store and order a 2x4 with a length of 3 sine squared, or sine of 40. That makes no sense. So plug it into your calculator, tell me what x is.
1.9283.
1.9283. So we'll go 9.3. Does that answer make sense?
Yes.
What answers wouldn't make sense?
0 or negative number.
Anything greater than 3, why?
Because it can be bigger than hypotenuse.
Good. What other answers wouldn't make sense? Negatives wouldn't make any sense because we're still dealing with distances here. What if I got an answer like, well, let's wait. Let's solve for y first, then I'll ask the question I was about to ask. If we stop here, we can find y a couple different ways. Knowing what you already know, how can I now find y? Pythagorean theorem. Okay, but there's a problem there. The problem is that we'll get an inaccurate answer. Okay, so on your calculators, take the square root of 13. What do you get? Okay, so you get some big long number, right? Now take that answer and square it. Where do you end up? Should end up back at 13, yes? Any problems? Okay. However, take 3.6 and square it. What do you get? You don't get back to 13, correct? So my point being, we want to try to avoid using calculated information unless we know that it's 100% accurate. If you get an answer like 4, then by all means use 4. Or 90 minus 40 is exactly 50. We could use that if we want to. In other words, I want to avoid Pythagorean theorem here, and I'd like to use trig. so from this 40-degree angle, we still have the hypotenuse being 3 because that never changes. What side is the value of y? Opposite or adjacent?
Adjacent.
Adjacent, because we already used the opposite side. What function uses adjacent and hypotenuse?
Cosine.
Cosine. Set up an equation. Cosine of 40 is equal to y over 3. Multiply both sides by 3 and tell me what y is, please.
2.2, no,
2.3?
yeah, around there.
Okay. Can somebody confirm? Yeah, we're good? Okay. Does it make sense that x would be smaller than y?
Yeah.
Yes. Why?
It looks smaller.
Longer, right?
How do you know that's longer?
Isn't the thing we were doing last week, that side was supposed to be 2 on A?
No, because that's only for those two special types of triangles, and that's not one of those triangles. How big would the angle have to be for x and y to be the same value? 45. Ethan, question?
No.
Just stretching?
Like answer.
Oh, go.
What? I just answered your question.
Oh, gotcha, okay. And then you just left your hand in the air like you just don't care?
Yeah.
Okay, beautiful. Let's suppose the angle, instead of being 40, was 75 degrees. Which side would be bigger, x or y?
Why?
Wait,
X.
Why?
Why?
C, L, and then P.
Good? Which one is it?
Why?
X, Y, Z, M,
What's the question?
If the angle measure was 75 degrees instead of 40, which side would be bigger, x or y?
Why?
It'd be X.
X would be bigger. So if the angle is bigger than 45, then the opposite side is larger. If the angle is less than 45, then the adjacent angle is, or adjacent side is longer. And if it's equal to 45, they are equal to each other. Any problems so far? We're good? All right. Let's try another example. Somewhere in here. All right, solve for R and S. This time you're on your own.
So the hypotenuse.
Okay, before you start calculating, let me ask you a question. Will S be bigger or smaller than 35?
Bigger.
Why?
The hypotenuse.
This hypotenuse, good. Will R be bigger or smaller than 35?
Smaller.
Smaller, because the angle is less than 45. Okay, good, solve. Accurate to 2 decimal places.
Okay, find the F.
In case you hadn't noticed, be careful where that right angle is.
Yeah. So wouldn't you be tan?
What do you put in for the hypotenuse?
Sine 15 equals
Which one are you gonna solve?
That's what
But what do you solve for? Solving for R and
So like,
yeah.
Okay, so is using the angle is R.
Yeah, I'd have to take hypotenuse. So tan is tan 35.
Oh, we don't
No, I
have.
think it's the angle measure.
That angle 15.5 is hard to get on the opposite side. We put it opposite. And we don't know the hypotenuse, so use the other side. 35 is adjacent or
So
hypotenuse.
35, 10.
What function uses opposite?
35, 10 times 15.
There you go. Set
I
up
got,
equations.
no, that's not, actually, yes, maybe. Yeah.
Can proceed then.
I got 9.706. What would that measure be? 2 sevens?
90-degree angle. Oh, you flipped over the triangle? Okay.
You have to put 35 in front of it.
R is the opposite side.
Why?
Yeah, but you know how long S is? So don't use that function. Use which information, use what
Did
information.
you guys get 9.70?
You're not supposed to.
It would be all over 35, right?
Use
Yeah,
this.
R over 35. And then you multiply both sides by 35. Yeah, I think it is.
35.
Yeah. R equals 9.70.
Actually, variables.
So it'd be
You could solve that now that you have two equations, but you don't want to go there. All right, so here's the problem that we're running into, is that you've decided what function you want to use ahead of time. So a lot of people are like, well, I want to use the sine, because R is the opposite side and S is the hypotenuse. So if I set up the following equation using the sine function, the sine of 15.5 is equal to R over S. What's wrong with that? Two variables, not solvable. Don't do that. What you should do is be a little bit more flexible and decide which function works for you. I'm going to deal with this angle. Yes?
Yes.
Okay. I'll solve for R first. Opposite, adjacent, or hypotenuse? Opposite. The other chunk of information I have is this 35. Adjacent or hypotenuse? Adjacent. So I'm looking for the opposite side. I know the adjacent side. What function uses opposite and adjacent? Tangent. Then use the tangent to set up your equation. Tangent of 15.5 is equal to? R over 35 or 35 over R?
R over 35.
R over 35. Okay, so 35 times the tangent of 15.5 equals R. R is equal to?
9.7.
9.2 decimal places?
9.70.
Okay, thank you. 9.7 then.
Yeah, 9.706.
That works.
Oh, it'd be 1 then.
Oh, it would be a 1 in there, huh? Okay. Okay, so you understand what I'm saying? Don't go into the problem just deciding I'm going to use sine, I'm going to use tangent. Okay, let's do S. This is still the adjacent side. And by process of elimination, we know that this is the hypotenuse. What function uses adjacent and hypotenuse?
Cosine.
Cosine. Cosine of 15.5 is equal to 35 over S. Uh-oh. How do I solve it when the variable's on the bottom?
Multiply both sides by 136.
Well, yes, but then you have to do about 9 more steps to get there. That's an S. Yeah. So here's what you would do from a mathematical standpoint. You multiply both sides by S, then you divide by the cosine. I'm going to show you a shortcut, and it's what I call the switcheroo. When my variable is on the bottom, I'm going to switch these two locations. So the S goes over here, the cosine of 15.5 goes underneath, and I get S is equal to 35 divided by the cosine of 15.5.
How do you write that into your calculator? You just write 35 divided by.
Type it just like it appears. 35 divided by the cosine of 15.5.
2.25.
36.3.
Oh, wait, what were we supposed to do?
36.31.
Oh, yeah. I didn't have it.
36 point, Andy, what'd you say? 3-1? 2-1. 3-2. Okay. Do those answers make sense?
Yeah.
Yes.
Well,
How-
Wait,
Yes.
No.
wait.
no.
Oh, yeah, it's the hypotenuse.
Hypotenuse should be the longest. How big is this angle, by the way?
9.7.
34.5?
74.
74.5, correct.
Oh, angle. Oh.
So this is 74.5. And we have three side lengths. 35 and 36.41. What you should start to notice is a little theorem we call the small, medium, large theorem, or SML. SML says the following. The smallest side is always opposite the smallest angle. The medium side is opposite the medium angle. The largest side, also known as the hypotenuse in this case, is opposite the largest angle. You can use that to check to see if your answers make any sense. Okay? Well, we're not done yet. Now we're done. Okay. Homework day 4. Okay. Tomorrow, what we're going to do is figure out, if we know the sides of a triangle, how to find the angles. Okay?